A ray of light is inciding normally on refracting face of prism of angle A and suffers deviation of angle del. We need to prove its refractive index to be sin A plus del by sin A. So firstly we will draw prism as this one. This is incident ray at an angle 90 degree. It interacts with this surface. Let us draw this one as normal, and this line is already normal because it is normally inciding, and angle of incidence is 0. Here this is angle A. We will extend this normal and this one will be R2. This ray suppose goes this way. So of course angle of emergence E is this one, and if you want to find the deviation cause, so this is deviation, you will extend this ray forward and measure its angle with emerging ray. Now I hope diagram is clear. Here this R1 is 0 degree, okay, because when any light ray is inciding normally on a surface, it will not get refracted to either side, or it won't deviate from its path, it will just go straight away. So here R1 is 0. Now we will get to the formulas. We know that angle of prism is R1 plus R2. So here R1 is 0. So of course angle of prism is equated to R2. Now second thing is, you can measure angle of emergence in there. If you see clearly, then this R2 can be written as E minus del. R2 can be written as E minus del. Now, in order to find refractive index of this prism, we can just simply use formula at this point. Here sin R2 upon sin E is equal to refractive index of outer medium. Suppose this is N1 and this is N2. So this is N1 upon N2. Now we have refractive index of prism with respect to the medium as N, which is given in question, and sin E upon sin R2 can be simply written as sin of, what is angle of emergence? A plus D. You can simply take this in there. So this is A plus deviation upon sin A, because R2 is equal to A. If you are done with this, I have a question for you. If you take the similar prism, angle of incidence as 90 degree, but the only thing that differs is the deviation. Here you can see that deviation is given by this sign. So what will be formula for this case? Will it be this one or it will be something different. So I guess most of you will come to the conclusion that refractive index in this case will be sine A minus del upon sine A. If you say that this is the final answer and the minus sign will exist here definitely, then you are wrong, because this del actually here should be converted as per sign convention, because here this deviation is measured in anti-clockwise sense. So this del must be used in negative sign convention. So this gives you same formula when you replace del by minus del because of anti-clockwise sense of its measurement. Here we have measured it in clockwise sense and hence it was positive. Here being anti-clockwise it must be negative, and this can make a blunder if you forget to give proper signs to it. This is the definite formula for any of the given cases of deviation. But you must put it with sign convention, okay?